Okay, so let me hide this. Okay, so today we'll be looking at right triangles. If you missed the first class, you can look at the handout. It's on Google Classroom. I think it's a good idea to be familiar with it. It's just a Pythagorean theorem if you missed it. But yeah, that's it basically. Okay, so this is just a refresher from last class. You guys can try it out. Make sure you understand the prerequisites. And if you have the answer, you can chat me or say it out loud.
Basically it's a square. Well, the opposite squared plus the adjacent squared equals the hypotenuse squared.
Yeah, that's true for the first question, right?
Yeah, for the define cos A thingy.
Oh yeah, that's right. But that's actually the Pythagorean theorem. I'm just asking for the cosine of A. And we'll learn that later, so don't worry about it if you don't get it. But let's, oh, sorry about that. For the first question, we're trying to find x. Sorry for the noise. So let me just write that down. Find x. Okay, well, we're getting some answers, so let's just try out the problem. So x, so we know the Pythagorean theorem, right? It says x squared plus x plus 4 squared is equal to 20 squared. So then we can expand this using the binomial theorem. This will be x squared plus 8x plus 16 equals to 400. So then 2x squared plus 8x minus 384, I believe, is equal to 0. X squared plus 4x minus 192 is equal to 0. And did anyone factor that? The quadratic? X is 12, okay. So once we, x plus 16 times x minus 12, okay, thank you, Ian. So this, move it up, x plus 16 times x minus 12 is equal to 0. So then this is a triangle. Obviously, the side can't be negative, so our only solution is 12. Did that make sense? Anyone have any questions? It's just a basic application of the Pythagorean theorem. Okay, and the next question, it's not really any math to do. Does anyone know the answer? Okay, that's fine because we didn't actually go over this, but we'll go over it in the next slide. Okay. So today we're going to be looking at, first thing we're going to be looking at is trigonometry. So, oh gosh, sorry. So you may have heard of SOHCAHTOA if you took geometry in middle school. And basically, it's just the values of the sine. We have three functions. They're called sine, cosine, and tangent. And usually we abbreviate them as sine, cos, and tan. Okay, so say we're looking at this angle, and let's call it theta. So then the sine of theta would be, okay, let's just label this adjacent here, adjacent, and up, and height. So if we have a right triangle, then the sine of this angle, this green angle, is going to be this side length over the hypotenuse, the opposite over hypotenuse. And then again, if we have the cosine, if we need to find the cosine of this angle, it's going to be adjacent over hypotenuse. And if we need to find the tangent of this angle, it's just going to be opposite over adjacent. And these are just some formulas you should commit to memory. It's just basic trig. So over here, this is just some different ways that angles might come up in math competitions. So you've probably all seen degrees. It's usually what we use in school, but radians, it's something different. So we can say that pi radians is 180 degrees. So instead of 180 degrees, we can write pi radians. But if we add 60 degrees, question. Yeah, Andrew, you're right, 360 is 2 pi. So does anyone know what 60 degrees would be in terms of radians? Aria, do you have a question? Yeah, so all of you guys are right. It's pi over 3 radians. So that's just simple algebra. We can prove this later with the unit circle if we have time, but it's not really, we don't really need it right now or for math competitions in general. Okay. So does anyone have any questions about these definitions?
In progress.
Okay, I'm assuming no. So let's try some problems. Oh, okay. And you guys can chat me or say it out loud once you're done. And just for reference, these may seem really easy. This isn't really what comes up on math competitions. I'm just trying to make sure you know the basics. So once we get to the harder problems, it's not like impossible. Oh yeah, we just did question 3 actually. I didn't realize. So yeah. How about this one? Does anyone have an answer?
What was the thing again? The sine cosine.
Oh, okay, so I'll go back to that slide. You guys can write it down.
Okay, thank you.
You're welcome. Okay, so let me rewrite what we had before. And I believe Alicia put the right answer for this question. Let me write that down. Okay, so it seems like a lot of you guys are getting the answer for all of the questions, so I'll just go over them. Oh, Andrew, do you have a question? Oh no, seems like that was a mistake maybe. Okay, so let's just do this one, it's really easy. Pi radians equals 180 degrees. So 3 pi, 3 to 1.5 radians, sorry, 1.5 pi radians would just be this one times 3 till, which would be 270 degrees. And this one, so we need to find the sine, cosine, and tangent of b. So does anyone want to explain this problem? I think you guys can use the whiteboard or in the chat. Okay, Matthew, you can explain it.
Okay. So using the Pythag theorem, we can basically find out that AC equals 10. Because no. Wait.
Is that right?
No, that's not right. That's not right. Wait, 15 squared is 225, so AC would be 200 root 200.
Yeah, so AC squared is 225 minus 25. So AC would be 10 root 2. Something going on in the chat. Yeah, so Ethan's right. It's 10 root 2. Okay. So sine of b, we know is opposite over hypotenuse. So let's just relabel our diagram to include this stuff again. So let's say this is opposite. Opposite is O, and adjacent is A, and the hypotenuse is H. And so if it doesn't make sense why this one is the opposite and why this one is adjacent, okay. Yeah, that's fine. Okay, so what I was saying, if it doesn't make sense, well, that was too fast. Okay. If it doesn't make sense why this one is opposite and this one is adjacent, just look at the angle of B. So relative to B, we need to find the only leg that doesn't touch it. So if you look at AB, it's obviously not AB, that's the hypotenuse, the longest side. So if you're confused if AC or CB is the hypotenuse, just look at the leg where like the leg that it isn't a part of angle B. So it's going to be this one, since no part of AC really intersects with this angle. So the opposite, okay, let's rewrite our definitions. So sine of B would be opposite over hypotenuse. Cosine of B would be adjacent over hypotenuse. And tan of B would be opposite over adjacent. So then we can just write these down. It's 10 root 2 over 15. Adjacent would be 5 over 15. And tan would be 10 root 2 is to 5. So does that make sense? Anyone have any?
You can simplify all three of these, right?
Yeah, you can.
Like for example, cos, like you could turn 5/15 into 1/3.
Yeah, you can simplify it. That's just, you should always simplify your answers. I just didn't do it. I got a bit lazy. So yeah.
Got it.
Yeah, good question. So does anyone notice anything special? This is just extra, but it's something really important to know. Yeah, we are, that's right, good job. So we're just gonna briefly look at
Sine times cos equals tan.
sine times,
What is it even now? Sine times the reciprocal of cos equals tan.
yeah, so sine times, okay, so let's look at identities, that's right. So what are we trying to say? Sine over cos is equal to tan. And Sophie, do you want to tell us why?
What did you say?
Do you want to show us why this is true?
Actually, I'm not that sure. I just noticed that.
Oh, well, that's okay. You are right. So sine is, so if we know we're working with fractions here, obviously you guys know how to divide fractions. This is what we have, right? So this is the value of sine, and this is the value of cosine. So then, yeah, so then sine over cosine, which is going to be OH times HA equals to OA, which is our value of tan. So this is true.
Okay.
Yeah, and that's exactly what I did. So that's the first thing. And then another important thing, let me do this. Oopsies. So does anyone notice something about sine of B and cosine of B? The hint is to look at the squares of them. Sine squared B and cos squared B. So sine squared B, moving up here, sine squared B is 8 over 9. Let me just write the whole thing. So we're going to look at sine of B squared. Oh, Sam, do you have something to say? Question? Okay, no. Sine of B squared, cosine of B squared is 1. No matter what B is, it can be 100, 50, 30, anything. This is always going to be true. So over here, if we look at it, it's just 8/9 plus 1/9, which is obviously 1. So why is this true? Does anyone want to try it out, how to prove it? Okay, so sine of B squared, we can just write it as O over H squared plus A over H squared. And obviously, since this is a right triangle, O squared plus A squared is going to be H squared by the Pythagorean theorem. So this is just H squared over H squared, which is 1. So this is something very important to know. So, is there anything more I'm missing? Oh yeah, one more. So, the last one is just sine of b equals to cosine of 90 minus b. And you can see why this is true. Let me erase all of this. So I'm saying sine of b is equal to cosine of 90 minus b. So let's call this angle b. And this angle is 90 minus b. So then sine of b is going to be opposite over hypotenuse. We already know that. But then cosine of 90 minus b. Does anyone know what that would be in terms of O, A, and H? It's actually not just A over H. So does anyone know why? Okay, so the cosine of 90 minus b, we need the side that's adjacent to it, the angle. So we actually need AC over the hypotenuse, which is also over H. So therefore, these are equal. So does anyone have any questions about that or this slide in general? Also, you may want to write these formulas down, 1, 2, and 3, just because they're so important. Okay, so no questions. I'm going to move on. Actually, I'll post the formulas in Classroom, so don't worry if you didn't get to copy them down. Okay, so the next thing we'll be looking at is just common values of trig functions. So nothing much to say. You should just memorize these basically, especially the red ones, because they show up a lot in math competitions. So yeah, I'll just skip this slide because I'll post this in Classroom. You can look at it in your own time. Okay, so now let's look at something very important. This is called the special right triangles. Basically, oh, sorry about that. Basically, we have, these are called special right triangles because their ratios are very special. So the first triangle, it's when our angles are 30, 60, and 90. So in a 30, 60, 90 triangle, this will be the ratio of the sides. A is to root 3A is to 2A. And then the isosceles right triangle, it's basically when we have a 45, 45, 90 triangle. This is isosceles, obviously. Two angles are the same. So this will be the ratio of our sides here. And actually, you should definitely remember these. It's very, very important. So using these, we can find the values of these functions over here. So does anyone know how we can do that? How we can calculate the first one? Using just this diagram. You can type it in the chat. Question is just, what is cosine of 45? No one? Remember that cosine is just adjacent over hypotenuse. Yeah, so Ethan, that's, yeah. Okay, a lot of people are getting it now. Yeah. Yep. Okay, so cosine of A, it's just going to be adjacent. This side is adjacent, remember, because it's the leg that's touching the angle over hypotenuse. So cosine of 45 will be A over root 2A, which is 1 over root 2. Or you can write root 2 over 2. And you can do the same thing for sine of theta. It's basically the same thing. Okay. So next thing we'll look at is we'll just look at one of these. So the next question is going to be, what is sine of 60? Sine of 60 equals to what? Using just this diagram. Andrew, are you sure about that? Because look, see, all the sides have scale of A. Are you still sure about that? Because we know sine of, so let's draw another right triangle right here. Okay. Opposite, adjacent, hypotenuse. So sine of A is equal to AD over H. Oh, okay. That's fine. Okay, yeah. So a lot of people got root 3 over 2. Ria, that is correct. Alicia, that's correct. So yeah, that's basically all we did. Sine of 60 is going to be root 3a over 2a. Which is just going to be root 3 over 2. Anyone have any questions about this? These problems, special right triangles? Okay, just make sure you completely have these memorized. Yeah, because they come up a lot. They're very important. Okay, so here's some problems, word problems. You guys can try it out. Send me your answer in chat. And these problems are more like what comes up in math competitions, but they're still pretty simple. Okay, so I saw a lot of you guys are getting the first one. So Alicia, do you want to explain it? Because I think Alicia was the first one to get it.
Okay.
Did you have the whiteboard?
Yeah, I can annotate.
Oh, okay, nice.
So the yield sign is an equilateral triangle, meaning that each of its angles is 60 degrees. And if we add an altitude from the top point down, this would be 90 degrees, and 60 divided by 2, because it's an equilateral triangle, would be 30. And that gives us a 30, 60, 90 triangle. And because the length of one side is 34 inches, that would be the hypotenuse. And this part down here is just 1/2 of 34, and that would be 17. And because of the property of 30, 60, 90 right triangles, the height would be 17. It would just be 17 square root of 3.
Yeah, that's right. That's basically the easiest way to do it. And yeah, 1 second. Okay, so nice job, Alicia. That was exactly what I was going to do. Okay, so Ein's going to explain the second one.
All right, so my microphone, I mean, there's probably a lot of background noise, so I'm not going to be using my mic for this, so I'll just do it on the whiteboard.
Okay, sounds good. Let me wait, Ein, do you want to move it up a little bit? Or like right here, like right underneath the yellow box? Because it's like cutting off a bit.
Okay, sorry.
Yeah, it's fine. Yeah. Yeah, that's right. Nice job. So you basically just used 45, 45, 90 triangles, but just directly with the Pythagorean theorem. So another way you can do it, actually you can basically the same thing, but since with the 45, 45, 90, this isn't supposed to be round, it's right angle. 45, 45, since this is the key. So we know this is 92. By 45, 45, 90 triangle, this will be 92 over root 2. It's basically the same thing, 46 root 2, but it's just a lot easier to calculate, because in math competitions you don't have a calculator, so you can pretty much just do this in your head. But this is also right. It's the same thing. Actually, you can, yeah, basically what Andrew said, you just do x root 2 is 92, and you get the answer. So does anyone have any questions about these problems or different ways to do it? Okay, no. So let's move on. So these are angles of elevation and depression. This isn't much math. It's just definitions, because in some problems they use these terms. So an angle of elevation is the angle from the horizontal upward to an object. So right here is the diagram. So let's just make a fake example. Say we have a human and he's looking straight upwards. No, sorry. This is his line of sight. Say there's an airplane. Airplane. It's very bad drawing, but makes the point. There's an airplane directly here. So then we can make a right angle here. And this would be called the angle of elevation. So A over here would be the angle of elevation from the guy's eyes to the plane. Yeah, it does look like a fish. I'm not the best artist. Okay. So then we also have the angle of depression. So once again, it's basically the angle from the horizontal downward towards an object. So once again, Sophie, do you want to draw a diagram for this one? Does anyone want to make up a fake scenario for this?
Can I?
Yeah.
I'm Sophie.
Oh, Sophie. Sophie, you can. I can't really see who's talking. So Sophie, do you want to draw an example?
Okay, wait a second. So this point, it's not good. Okay, so say there's a guy right here. And then this is his line of sight, like when he's looking straight forward. And then say he's standing on the edge of a cliff. And then there's this pond at the bottom of the cliff. And he's looking at it. So this would be the angle of depression.
Yeah, that's right. So yeah, that's a good example. So someone else said they want to share an example. I think Ria, do you want to share another example?
Yeah.
Okay, so you can draw on the whiteboard.
So like, say there's a person and beneath him there's like, say this person can walk on water.
Mhm.
And there's a fish beneath him, like a tadpole maybe.
Okay.
And this is his line of sight when he's looking straight forward. Actually, a fish is right here. Fish is right here. And then when he looks at the fish, that's like his angle.
Yeah. Okay, yeah, that's right. Nice example too. So I'll just clear everything. Thank you for sharing. Yeah, that's basically it. Nothing much to it. So let's solve this problem. It actually uses special right triangles too. So good idea to remember them.
This is a lot like the one I just used.
Yeah,
The
it's,
guy sitting on the cliff looking at the pool of water.
yeah, yeah. So you can chat me once you have the answer. Okay, so it seems like you guys are getting the answers. I'll just wait a little bit more. And I'll start drawing the diagram. Well, some of you guys are close. I think you guys are just you have the right approach. I think you guys are just forgetting the ratios. So I'll write the ratios down, then you can resolve them. Now just redraw the special right triangle here. Side ratios are going to be A is to A root 3 is to 2A. Wait 1 second. This is
Why is it called the angle of depression?
because like depression, it's going down.
Okay.
It's a fancy word. Okay, wait. So let me just make sure the thing item is right over here. Hello. Maybe I do the diagram. Okay, let me get rid of this. Oh, hold on. Oh wait, I did mess up my diagram. So this is the real diagram. Okay, so hold up. I messed up. 1 second. It's on the 60. Okay.
Maybe if you go to the previous slide and then come back.
Yeah. Okay, so basically I messed up the angle of depression in my diagram, so angle of depression, should always be the angle it forms at the ground, not the human. That should make sense. Sorry about that. So does anyone want to explain it? Like on the whiteboard? Okay, wait, Andrew. Wait, Andrew, I think you're still off. Okay, Matthew, you can explain.
Oh, okay. Since we know, they tell us that the angle of depression thingy, like over here, is 60, that means this part has to be 30.
Mm-hmm.
And we know this is a right triangle, so this is the 30, 60, 90 triangle. So basically, this would be x root 3, I think. So 40 would be x root 3.
Mm-hmm.
Which means that x would be 40 over root 3, which, to put in better terms, would be 40 root 3 over 3.
Yeah, that's right. So it's actually, yeah, that's right. It's actually pretty easy to mess up this problem because basically what I did, my mistake was assuming that this angle was 60. That's wrong. But usually in math competitions, they don't say like angle of depression. They say it more clearly. So yeah, so if you made that mistake, you shouldn't worry about it. It's just, yeah, I just wanted to, comes up in school, people in school geometry, they say angle of depression, elevation, whatever. But like in math competitions, they just directly say it. So don't worry if you like made this one 60 or this one 60. Okay, so let's move on. How much time do we have? Oh, we have like 5 minutes, so let me move on. Inverse trig functions. Let me see what we have. This isn't very important. Okay, wait, never mind. That's all we have left. Okay, so basically, can you guys see this yellow box? Because I can't see it. Okay. So basically, a thing is, another concept we have is called inverse trig functions. So basically, inverse trig function, it's when we're given the sides, but we need to find an angle in a right triangle, obviously, for now. Say we have this. And they want us to calculate this angle, A. So finding this angle A would require the use of an inverse trig function. So inverse trig functions, basically, what do we know? Oh, lots of stuff in the chat. Seems like it's from the last problem. Okay, so an inverse trig function, it's basically we can write sine of A, just in this example, sine of A would be root 3 over 2. But how are we going to find A? So does anyone know what A would be? Okay, I think we still have some confusion about the previous problem. Let me go back to that. Okay, so this is the problem. This is the cliff. This is the cliff, okay? Oh, oops, cliff. And we need to find the distance from the seal to the cliff, so that'd be x. Yeah, okay. Okay, let's move on. Yeah. Okay, so what we were doing, we had a triangle. we're given sides. And we need to find this angle A. So does anyone know how we would find A, just given these side lengths and the fact that this is a right triangle? Okay, well, I am the right root. Well, sine of A would be root 3. Sine of A would be root 3 over 2. But we need the degree measure of A. Like, what is A? Wait, Matthew, I'm not sure what you're trying to say. I'll go over that. Oh, I think I'll go over that in a bit, like what this thing means right here. Well, Ian says you need a calculator for this, but usually you do need a calculator. But this thing is root 3 over 2. It's a very common value. So in a special right triangle, what is the sine of 60? Given this, obviously. Yes, sine of 60 would be root 3 over 2 in our special right triangle. So obviously A is going to be 60. So usually for these type of problems where you're given the sides and you need to find the angle, you need to use a calculator. But that's not in math competitions. Math competitions, they'll give you common values like these over here. So that's why it's really important to commit the special right triangles to memory. Because if you're given the value of a sine, then you should be able to find the angle. So did that make sense?
What is arcsine and arccos again?
Okay, yeah. So I'm gonna go over that right now. So basically when we're given this thing, so we're given the sides and we need to find the angle theta. So theta, we use something called inverse sine on a calculator. If you have a calculator, you can find something that looks like sine to the power minus 1. It's actually not. Hypotenuse. So this is theta. This is just a mathematical way of saying it. But if you're getting confused, you keep on thinking this is not true. Then you can just say arcsine of opposite over hypotenuse. So this
Okay,
just,
so arcsine is 1 over sine, right?
no, it's not. It's sine of minus 1. It's just a way of saying it. It's literally not 1 over sine of x. I don't know why mathematicians chose to do that. They just did. But this is not true. It's not true. It's just sine of minus 1. That's the simplest form you can leave it. Sine of minus 1x. You can't do anything with this except plug it into a calculator. Or you can write it as arcsine of x. So just forget that negative exponents exist when we have a trigonometric function to the power minus 1. So does that make sense? I know it's pretty confusing with the exponent. Okay, so basically that's what we did. As you can see in the yellow box, if the negative exponents are confusing you, you can just use arcsine instead of this. And over here, I won't go over this. You should just have these memorized. And I think we're almost out of time. we are, but this is just a quick problem. These aren't good problems. Let me draw another one. Actually, don't use a calculator, just do this one, but leave your answer in arcsine form. So you guys can try this one. Yeah, so that's right. Do you wanna draw it on the whiteboard again? Okay. Okay, so yeah, so that's right. Ian's right. Does anyone have any questions about this problem? Because we'll end class right after this one. Okay, seems like there's no questions. So yeah, that's basically it for today's class.